Hello everybody. Welcome back to the last lesson of the chapter Quadrilaterals. So our lesson today is the midpoint theorem. As the name says, it is connecting two midpoints. Let D be the midpoint of side AB, which means AD and DB are equal, and E is the midpoint, means AE is equal to EC. This is the given condition. Now we have to show that the side DE is parallel to BC. This is what we have to show. This can be showed by a construction. Let us draw a line through C, which is parallel to AB. These two lines are parallel, it is a construction. And we can extend the side DE to meet C to F on the line CF. Let us see how does it work. In this triangle, D and E are the midpoints. We know these two are equal. These two sides are also equal. Now, CF is parallel to AB, which means these two lines are parallel. Now we have to show that DE is parallel to BC. This is what we have to show. For that, consider the triangle ADE and triangle CFE. We can see that AE is equal to EC because it is the midpoint. E is the midpoint. Now we have a vertical angle. AED is equal to CEF. Angle AED is equal to angle CEF. Also, AB is parallel to CF, so we can find an alternate interior angle, the Z shape. So the angle at F is equal to the angle at D. So angle ADE is equal to angle CFE. Alternate interior angle between the lines AB parallel to CF. So we have angle side. So by AAS triangle, ADE is congruent to triangle. We have to be careful now. D with F is the same, E with E is the same. So F and E should be the last two letters, F, E. So it should start with C. These two triangles are congruent. So by CPCT, we get the side CF is the same as AD. AD and CF are the same. CPCT. But AD is equal to DB. Because D is the midpoint. So from these two conditions, we get AD and AD is common. So CF is equal to DB. Therefore, CF is equal to DB. DB and CF. So these two sides are equal. And we also know that they are parallel because by construction. DB is parallel to CF by construction. So one pair of opposite sides are equal and parallel. Because one pair of opposite sides are parallel and equal from these two conditions. One pair of opposite sides are parallel and equal, which means DE is parallel to, therefore, DE, which is a part of the parallelogram, is parallel to BC. Opposite sides of a parallelogram are parallel. That was what we have to prove. Let us see the opposite of this theorem. The opposite of this theorem says that, or the inverse of this theorem says that the line drawn through the midpoint of one side of a triangle means we are only given midpoint of one side. Let E be the midpoint. F is a midpoint or not, it's not given. But another condition given is that parallel to the third side, these two lines are parallel is given to us. Then it is given bisects the third side, which means then it will be equal to this. This is what we have to prove. It's not given. Once again, given condition is E is the midpoint, AE is equal to EB, and EF is parallel to BC. So once again, we will construct from C to F such that CF is parallel to BE, and we will connect to the point. This time it can't be F here, so let us say M or any other letter. So we'll see how is it. So draw CD parallel to BE. So these two lines are parallel. AE is equal to EB because E is the midpoint. And these two lines are parallel is given to us. Now what we have to prove is AF is equal to FC. This is to be proved. Once again, let us consider the triangle AEF and CDF. In triangle AEF and CDF, we can see that CD is equal to BE because EBCD is a parallelogram. Why is it a parallelogram? Both pairs of opposite sides are parallel. Both pairs are parallel. So because this is a parallelogram, we have opposite sides are equal. So we get one side now between these two triangles. Now we have CFD is equal to AFE. Angle AFE equals angle CFD, vertically opposite angles. So we have a side now, we have an angle. Once again, these two are parallel, so we can see the Z shape. Alternate interior angles are equal. Angle AEF is equal to angle CDF. Alternate interior angles. Between the sides, AB parallel to CM or MC. But EB is equal to AE because E is the midpoint. From these two conditions, we get EB and EB are common. CD is equal to AE. So by AAS, triangle AEF is congruent to triangle. Again, we have to keep E and F the last letters, so DF, CDF. What was our target? To show that AF is equal to CF. AF is equal to CF. Therefore, AF is equal to CF because corresponding parts of congruent triangles. That means F is the midpoint. So what do we understand from here? It is an inverse of midpoint theorem. If you start from the midpoint of one side and which is parallel to the third side, then it will join the midpoint of the second side. That is the inverse of midpoint theorem. Let us see an example related to midpoint theorem here. In triangle ABC, D, E, and F are the midpoints of the side AB, BC, and CD, which means AD is equal to DB, BE is equal to EC, and CF is equal to FA. These are given conditions. Show that ABC divides it into 4 congruent triangles. For that, we have to apply the midpoint theorem. Considering the parallelogram DBEF, we can see that DF is parallel to BE by midpoint theorem. DF is parallel to BE by midpoint theorem. What was midpoint theorem? Just a quick review. A line joining the midpoint of a side to the second side will be parallel to the third side. So these two are parallel. And also, as an extra part from the midpoint theorem, we found that the line joining the midpoint will be half of the third side. So we get DF is half of BC, which is equal to BE, because E is the midpoint. So this is also by midpoint theorem. So when DF is equal to BE, therefore DBEF is a parallelogram, because one pair of opposite sides are equal and parallel. We have studied that the diagonal of the parallelogram cuts into 2 congruent triangles. So we can see triangle DFE is congruent to triangle EBD, because diagonal divides the parallelogram into 2 congruent triangles. Let's say triangle 1 is congruent to triangle 2. Once again, when you consider the parallelogram DECF, so triangle 1 is congruent to triangle 3. Again, we can see that ADEF is a parallelogram. It cuts into 2 congruent triangles. So triangle 1 is congruent to triangle 4. Therefore, the whole triangle is therefore ABC. The triangle ABC is divided into 4 congruent triangles. Let's move on to another example. L, M, and N are 3 parallel lines intersected by transversal. So these 3 lines are parallel, and P and Q are transversal, such that it is equally cut off by the intercepts AB and BC. Equally cut off means AB is equal to BC. It's given to us. AB is equal to BC is given. And we also know that BG is parallel to CF. BG is parallel to CF because line M and N are parallel. So by the inverse of the midpoint theorem, we found that a line joining the midpoint of one side of a triangle parallel to the third side meets the midpoint of the second side, which means AG is equal to GF. Therefore, AG is equal to GF by the inverse midpoint theorem, MPT. So we found out that G is the midpoint. Now in the triangle AFD, we have G is the midpoint, which means AG is equal to GF from above. And GE is parallel to AD because the line M is parallel to L. So again, by the inverse of the midpoint theorem, a line joining the midpoint of one side parallel to the third side joins the midpoint of the second side. So we can find that DE is equal to EF by the inverse midpoint theorem. That's what we have to prove here. It's an amazing question. That's all for today, and the exercise we will solve it in the next period.